This next example comes out of section 6.4, solving trig equations using identities. We're asked to solve this equation, 2 sine x equals 7 minus 3 cosecant x. The first thing you might do in this instance is change the cosecant to 1 over sine. At that point, you may not have dealt with a lot of these where you have the variable in the denominator. Even back in Math 20, you probably would have seen maybe something where it said 2n equals 7 minus 3 over n. The best way to go about this is multiply both sides by n, meaning that we're going to have 2n squared equals 7n minus 3. In our case, it's the same idea. We're going to multiply everything by sine x. So we're going to have 2 sine squared x equals 7 sine x minus 3. Hopefully you recognize that as it sets up as a factoring problem. Bring everything to one side and let it equal to 0. Now if I'm able to factor this, I'll be able to figure out what these answers are. So I'm looking for two numbers that multiply together to equal 6, and they have to add together to equal negative 7. So minus 6 and minus 1 looks like our magic numbers. So I could say 2 sine squared x minus 6 sine x minus 1 sine x plus 3 equals 0. Factor them 2 by 2, and I've got 2 sine x times sine x minus 3 minus 1 times sine x minus 3. You could have paralleled this question again by just saying 2n squared minus 7n plus 3 equals 0, and you would end up with the factors that we're getting here, which would be n minus 3 times 2n minus 1. Here we're going to get sine x minus 3 times 2 sine x minus 1 equals 0. Leads me to two equations, sine x equals 3 or sine x equals 1 over 2. There is nowhere where sine x equals 3. In fact, sine x never goes any higher than 1, but there are some places where sine x equals a half. We've run into those lots of times before, and they are pi over 6 and 5 pi over 6. So these would be the only two solutions between 0 and 2 pi that satisfy the equation given at the top.